analysis of the waveguides. Samuel, you can take over.
Okay, question 3 says, allow me present. Yeah, I hope you can see my screen. Question 3 says, a rectangular waveguide with the dimensions as A 2 centimeters, B 1 centimeter, filled with the liquid with mu r1 epsilon r81. It operates at 3 gigahertz. So we have to determine the first 8 propagating modes and their corresponding cutoff frequencies. Okay, allow me use the okay, so we are asked to find the first 8 propagating modes for the rectangular waveguide with the dimensions okay, so we have A as 2 centimeters, B as
Hey, oh, am I the one not seeing your presentation? Probably. Oh, there you are. It's there. Excellent.
I hope you can see the presentation.
Yes, I can see it. I was on another page.
So we have mu r as 1 and epsilon r as 81. So we have the formula for cutoff frequency as the general formula as C over 2 into epsilon r mu r square root of m over a squared plus n over b squared. So if we are to find the first 8, I think the best way is to put these into the calculator so that you can populate for different values of m and n. Okay, so we have Fc into speed of light over 2 into we have mu r as 1 and the other one as 81 into the square root of m over a in meters plus n over b is 1 centimeter. Now if you just put these into the calculator and now you change the values of m and n. The first 8, starting with the dominant, will be TE10 at 0.833 gigahertz, then TE20 at 1.667, then TE 01 1.667, then TE11, which will be the same as TM11 at 1.863, one at 2.357 gigahertz, which will be the same with TM21. Then you have TE30 as 2.5 gigahertz, and the operating frequency is 3 gigahertz. Yeah, so these are the first 8 propagating modes that I found. I don't know if that's the same answer as everyone's. Hello? Stephen?
It's okay.
Okay. Yeah, so that's question 3.
I have a question. How do we determine whether it's TE or TM?
Yeah, so TE11, find the cutoff frequency for TE11, for example. The formula is the same as TM11, finding the cutoff for TM11. So I'm tempted to say they are degenerate modes because they have the same cutoff. So TE11 has the same cutoff frequency as TM11. Same goes to a 21, TM21, and TE21. I don't know if that's correct. Alphonse, kindly assist. Alphonse.
Like, how do we determine whether it's TE or TM?
Lennox, you could assist.
Okay.
Yeah, I'm of the same opinion as Lennox. Of course, we don't have any TM mode with a zero. Yeah, but now as Alphonse was saying that A is greater than B. Yeah, of course, the dimensions we're used to having uh the the dimension A being greater than B. But does that help in determining if it's a TM or a TE? Because my opinion was that the formula for calculating, okay, I was of the opinion that calculating TE11, the formula is the same for as of calculating the TM11 with the same dimensions A and B. So now we'd have TE11 having the same cutoff as TM11.
Yes,
Maybe
Kidogo.
Alphonse, you could unmute and assist us.
Can you hear me?
Yes.
Okay, I think we just have to calculate the cutoff frequencies of the dominant modes. We know that in TE10 is the dominant mode, and then we also calculate the cutoff frequency for the TM11, and then we compare which one has the higher frequency. So we go with the one which has the lowest frequency. So for example, in this case, we see that TE10 has a frequency of 33 megahertz. So that one, we can just assume that it is the dominant mode. Yeah.
Great. Could you kindly? Yeah. So Alphonse, as per Sherry's question, she was, I think what I got was, how do we know we have a TM11 and not a TE11? And my response to that was that TM11 and TE11 are, they have the same cutoff frequency, so they are degenerate.
Alphonse, could you please repeat the explanation that you are giving?
Okay, my idea was to just, we know that the dominant modes in TE is 10, and then the dominant one for TM is 11. We calculate the cutoff frequencies. We see which one has a higher cutoff frequency, and we see that in this case it is the TM11, and then we compare it to the value for the TE10, and then you find that the frequency for TE10 is lower. So because it is lower, it is most likely that it is the dominant mode, because FCTE10 is 833 megahertz, and then FCTM11 is 1.863 gigahertz, which corresponds to also FCTE11. Yeah. So you just choose that the lowest frequency is the one with the is the one for the dominant mode.
Okay, is there anything else arising from question 3 for anyone before we go to the next question? If there's nothing, we can go on with question 4. Someone else with a whiteboard can share it and go through it. Gasta, could you go through question 4?
Okay, fine. Just give me like a minute to set up my whiteboard.
Can I share? Surfing.
Yes, you'd like to share?
Yes.
Okay, go ahead.
Can you see my screen? Okay, so question 4, we have been asked to find the limits for the permittivity, relative permittivity, so that only the dominant mode propagates. So we have that our and then we are investigating TE10. The frequency is 6.6. So we have been asked to find that. So we know that for propagation to occur, F must be greater than the cutoff frequency. So it means that 6.6 gigahertz is greater than FC. So we know that FC is equals to so we know that that's the formula. So and in TE10, N is M is 1 and then N is equals to 0. So FC becomes C over 2 root of ER times 1 over A. So for us to find this cutoff frequency, we just equate it with the frequency of operation, which is given as 6.6. So 6.6 times 10 power 9 because this is the value, this is the parameter that we are interested in. So we find that for the cutoff frequency to be at 6 gigahertz, the value should be at 1.067. So it means that for propagation to occur, therefore, ER must be greater than 1.067. Must be equal to or greater than 1.067. Yes. Is that okay?
Any questions? Yes, Samuel.
Yes, I had a question. Is that the limit will be from 1.067 to infinity, or there's an upper bound or a lower bound limit?
Okay. If we say that it should be greater than 1.067, it means that the frequency of the wave will be greater than the cutoff frequency of that mode. So in ensuring that it's greater than 1.067, it means that the frequency will not be anything less than the cutoff frequency. So we know that any frequency above the cutoff will propagate. I think so, yeah.
Yes, Ndessa.
I think you should find the cutoff frequency of the next dominant mode so that you can find the limits of the dielectric.
I think Alphonse can take us through the cutoff frequency for the next dominant mode, so you can have a range for it.
Okay, sure. So for the next dominant mode, that's the TE.
Yes, I am.
Can you hear me?
Yes.
So we have n is 1, 0, 2, 4, 2 squared plus 8 squared. So this become
They're all full. This is green.
Dr. Kwon, is there something you'd like to add?
So which question is this? I'm trying to multitask. It's really difficult. Which question is this? The one looking for the permittivity, the range?
Yes.
yes,
And you have what dimensions do you have? Do you have A and B?
yes,
Okay. So you're supposed to get one using A and the other one using B. And then you look at the two ranges, the two values.
okay,
Did you get the point?
yes,
You use A and then the other one you use B and get E, epsilon. Remember, it's normally just a convention that A is more than B, isn't it?
yes.
Yeah, but I hope to get somewhere just shortly to be able to follow what you guys are doing.
And then this one we equate it to 6. Okay, so let me just calculate this. Two squared. So done is equals to 4.982. So from these calculations, therefore, it means that the range should be greater than 1.067 and less than or equal to 4.982. Yes. So Ngeza,
It's okay. It's good. It's okay.
okay, sure. Yeah, that's it.
Dessa, could you take us through question 6?
Yeah, excuse.
Yes.
Yeah, I had some connectivity problem, but I was asking what have you agreed to be the mods for both TE and TM? Because somehow we have like contradicting conventions. Yeah, and I was somehow offline.
The modes as pertaining the question we've been doing or question 3? Ogola, is your question addressed to question 3 or is it addressed to the question you're doing?
I think it is the question concerning the where you are told you state the 8 modes of both TE and TM waves.
For the dominant mode, the one that would have, as was said by Alphonse, the one that has a low frequency between TE10 and TM11. Then from there, since the formula for cutoff frequency is the same for both TE modes and TM modes, for TM11 and TE11 both would be degenerate modes. Is that okay, Ogola?
Safin, just take note on where areas where there are no clarity, so that when I'm in class on Tuesday, you can ask me. Okay?
Yes.
Yeah, I'm not able to join. I'm to participate actively. So just take note of areas where people are not agreeing.
Guess you can continue.
Okay, for number 6. So number 6. Okay, a rectangular waveguide carries an electromagnetic wave having a frequency of 4 gigahertz. A standing wave indicator shows that the wavelength of the wave in the guide is 11.4 centimeter. What is the cutoff wavelength of the waveguide and the velocity at which the energy is propagated along the guide or group velocity? Okay. For this question, we have the frequency to be 4 gigahertz. Stephen, is it visible?
I can see it.
Okay. So our wavelength will be 3 times 10 power negative 8 divided by our frequency, which is 4 times 10 power 9. We'll get 0.075. Our guide wavelength will be our free space wavelength all over 1 minus the cutoff frequency over our frequency. But this can also the square root of this can also be expressed as 1 divided by the cutoff, the free space wavelength over the cutoff wavelength. So our cutoff wavelength will be our guide wavelength over 1 minus so we'll have 0.075 divided by 0.144. If we do this, it will be 0.9, 0.09959. This is in meters. Is this clear? For everyone, that is.
Yes, it is.
Okay, the second part of the question asks about the group velocity. The group velocity will be the cutoff frequency divided over 1 minus fc over f squared, which can also be expressed as c1 minus so this is 3 times 10 power 8 root of 1 minus 0.075 over 0.0959 squared. And we'll get our answer to be about 1.974 times 10 power 8 meters per second. That's all. Anyone with a question?
Yes, George.
I have a question on that on that particular question. Because the waveguide, we are not told the waveguide is filled by with air. Is it right to assume that the velocity there is an epsilon or the permittivity, and then we use the formula to get the velocity as lambda f, because we are given the wavelength over there, and we have the frequency. Can we multiply the two and say that is the velocity?
I didn't get you.
I'm asking because the waveguide, we don't know what is field or what the dielectric fielding the waveguide, and we are given the frequency of the wave, and we are given the wavelength as 11.4, and that's the wave the guide wavelength. Can we say the velocity is the frequency multiplied by the wavelength? We take that wavelength and we multiply by the frequency given to get the velocity. We say that is the velocity that wave is traveling inside the waveguide. Because of in your calculations, you have used c as the speed of light, and we do assuming that it is now air filled, it is traveling in free space, and we don't know what the electric is filling the waveguide.
Ochard, do you have anything to add on the same thing?
Yes, I have a concern because the question says a standing wave indicator shows that the wavelength of the wave in the guide. So the wave's wavelength is 11.4, but now as per the calculation, I'm seeing that we are kinda using the guide's wavelength as 11.4, yet from my understanding of the English in the question, I'm of the opinion that it's the wavelength of the wave is 11.4, not the guide's wavelength.
Maybe Stephen, you can you can mark that one, and then Dr. Akun, maybe we will clarify in class.
Okay, I'm noting it down. Anyone else would like to take us through question 7? The floor is open if you would like to share and take us through the question. Samuel, would you like to take us through question 7?
Okay, allow me share my screen. Yeah, I hope you can see my screen. Okay. Okay, question 7 says that a 6 gigahertz signal is to be propagated in the dominant mode in a rectangular waveguide if its group velocity is 90% of the free space velocity. What must be the breadth of the waveguide? Okay, so we have that as from the question, we are required to know, of course, that the group velocity is c into 1 minus fc over f squared, and we are told that the group velocity is 90% of free space velocity, so this is 0.9 c. And then your father told that a 6 gigahertz signal is to be propagated in the dominant mode in a rectangular waveguide. So we know that the dominant mode we have TE 10. Okay. So now we know that as per the latter statement that the group velocity is 0.9 of the free space velocity. So we can see from the above equation that 1 minus fc over f squared should be equal to 0.9. Squaring both sides, we will have 0.81 equal to 1 minus fc over f squared. And we have further rearranging this, we'll have fc over f squared equal to 1 minus 0.81. So of course we'll have fc over f equal to the square root of 0.19. So we'll have fc to be equal to this will be square root of 19 over 10 multiplied by the operating frequency, which was 6 gigahertz. So we have 19 over 10 times 6. So we'll have fc as 2.62 gigahertz for TE10. And the general cutoff frequency we know to be c over 2 square root of m over a squared plus n over b squared. So for FCTE10, we have it as c over 2a. Rearranging these, we'll have a to be c over 2 So we'll have the breadth as 57.3 centimeters. Yeah, that's how I did it, unless someone might have an addition or a correction. Seven.
Any questions? Any additions? Anything someone noticed we need to take note of? Okay. I'm not sure if we have enough time to do another question. Mhm. Dr. Akwen, are you in a position to take attendance?
Yeah, I should be able to record the attendance, so you can send them in. So we meet on Tuesday, and we'll try to go through them quickly, probably from my side. So Finn, just make sure you send me the ones that had issues, and then I will proceed from my side. I think I'll just be able to present on them.